Hello everyone, my name's Peter Shields and on behalf of AirMet Scientific, I'm very pleased to welcome you to today's webinar. Many of you attended our webinar on respirator fit testing using controlled negative pressure with the QuantiFit last month. Today, as a follow-up to that topic, we have a presentation on revolutionising wearer seal checks with the OHD QuantiCheck, the world's first quantitative user seal check device. Today, we're fortunate to have both Dr. Stephanie Lynch, the product manager from OHD Global, and the president of OHD Global, Mr. Luke Allen, to present for us.
Thank you, Peter. Thank you, AirMed, and thank you everyone for joining our presentation today. My name is Luke Allen. I'm the president of OHD, and again, I'm with Dr. Stephanie Lynch, our product manager. We'll jump into our presentation really quickly, but first a bit of background on our company. So OHD is a respiratory technology focused company that's around the health and safety of wearers and users globally. And we work to develop new technology that really meets needs in the marketplace. And we hope today, this morning, your time will be something that will be just that for you. So revolutionary and new technology. The main thing we'll be discussing today is a gap between fit testing, which many of you guys tuned in on the last episode or the last time they did a webinar on fit testing using CNP, all the way to nothing, or just what we call a wearer seal check. So daily use of respirators. So how do we know that masks work every time we put them on or every day of use? And that's what we're going to talk about today, of taking that to a whole nother level. So let's jump into our presentation and we'll let Dr. Stephanie Lynch take it from here. So Steph, I'll launch this so everybody can see it, and then we should be going.
So, well, thank you, Luke, first off, and thank you, Peter. If you've worked at all with respirators, then you're likely pretty familiar with a traditional wearer seal check. You're probably all familiar with the traditional wearer seal check. It's up on the screen now, the two different versions. And like Luke said, this shouldn't be confused with a fit test. And it's not providing the same assurance of fit, but it's supposed to help you assess your seal with every time you don that respirator. And they are typically required by regulation, and they would of course be advisable to help you, at least check for any big leaks. But a positive pressure check is going to involve closing off the exhalation valve and then exhaling gently into the face piece. And you're going to consider your face fit satisfactory if you can build up a slight positive pressure within that face piece without any evidence of leakage. And with the negative pressure check, you typically close off the inlet opening of the canister or cartridge. In the picture, the guy is using his thumbs. Some respirators might require you to use the palm of your hand. And then you're going to inhale gently so the face piece collapses slightly. And you're going to hold your breath. And if the face piece remains in that slightly collapsed condition and you don't sense any inward leakage, then the tightness of the respirator is considered satisfactory. So that's the current method. So within your respiratory protection program, once you've had a fit test conducted to determine the best respirator for a particular wearer, the wearer seal checks are going to be performed every time the respirator is put on to confirm that adequate seal. But these subjective methods basically just leave a lot to be desired. If you think your mask fits when you've donned it, then a typical wearer seal check, particularly a poorly performed one, is not going to provide much more confidence than that. And this check is supposed to be a last line of defense. If an adequate seal can't be confirmed by your user seal check, your wearer seal check, then you shouldn't enter a hazardous area. But so in practice, at least I personally, and I think a lot of other practitioners, have seen that these checks are often completely overlooked, and it's likely that that's at least in part due to the lack of perceived and actual value, right? Because like I said, if you already think your mask fits, that wearer seal check isn't going to really provide you with much more than that. So that's where the QuantiCheck comes in. It's the first ever quantitative wearer seal check device. So it allows for wearers to quickly and easily complete that check with measurable and recordable accuracy. So, because respirator wearers are currently required to rely on their own perception, it leaves room for a lot of doubt. They're perceiving that pressure buildup and or loss to perform their wearer seal check. So research has shown that this is also an unreliable check. It's not been shown to have a whole lot of value, but it's still better than nothing has kind of been the standard. So the QuantiCheck is taking out that doubt. It's evaluating the seal and integrity of the mask utilizing a pressure sensor. It's a quick but accurate check of the protection that's being provided by the mask. And a really important note is that it's going just beyond that seal. It's really checking the integrity. It has an optional app, but it also saves each test on the device. And this will allow for both the employer and the respirator user to have more confidence in the protection that's being provided by their respirator. So how is the QuantiCheck doing this? What is it doing? So the user engages the device and takes a breath and holds, similar in method to what you would do with that negative pressure user seal check. But at the lowest point of that negative pull of the user's inhale, the system is going to start a calculation. It's a proprietary algorithm. And so at 15 millibars of negative pressure pull, that's created by the user inhale, that's the minimum to start the check. And then there's a set maximum. And so then anything outside of that range, outside that pressure range, will either not start the check, it'll show an overbreathe, or show a fail. And the reason that it's just set for an overbreathe with that maximum pressure is that too much pressure can cause other issues with mask fit. That minimum 15 millibar is important because this ensures that the weakest point will be where the air enters the mask. So for example, either the filter or the regulator. And this is because the highest resistance in-use filter that's allowed currently is 8.2 millibar. So with that 15 millibars, the minimum pull, the resultant allowed pressure would be around 10 millibar at the end of a passed QuantiCheck test. And so that's a safe margin above those worst case filters for the masks currently available. So we're going to kind of go through this on the demo, and it'll be much more visible, but the steps are very straightforward. The user attaches the device to their respirator in one version, dons their respirator, and we'll get into versions and attachments a little bit later also. But dons their respirator, engages the QuantiCheck, takes a comfortable breath, and holds. And then they're going to get a visual indication of their fit. So either a pass or fail. Green light for pass, red for fail. Within the app, a respirator wearer can have access to more information about their check. So these are just some of the ways that that graph can come out, and this allows for a little bit of troubleshooting. A QuantiCheck pass will visually be that single large negative fluctuation that's on the user's inhale, and then a gently increasing line before the final rise that comes at the end of the check. And the troubleshooting that you're able to do, or some interpretation or troubleshooting that is possible with some of the other graphs, are that a sharp increase within the test would likely be indicative of a large leak. If there's a bump or anything, any kind on that initial negative pull with the slow, steady rise, if you get a bump in that, then the user might be having difficulty holding their breath. And then if you have an immediate sharp upswing, that would be a catastrophic leak. You're not getting any seal to your respirator. And you'd be able to see those visually with your graph, and it would allow for some troubleshooting with your foot. So also, in addition to the app, there's an optional cloud access. And on the cloud, users would be able to see a score. And the score is based on how close you get to the failure point of the QuantiCheck. that failure point that we see right here in the graph. This score allows for the monitoring of results over time. So user changes or possible damage to the face piece can be monitored based on a quality of pass indication over time. So how this score starts to go down. As with any negative pressure check, these results are going to change between any two tests, but we have found that over repeat use data, statistical changes can be looked at and potential issues can be highlighted before they cause a failed check, meaning before you get to the point that your respirator isn't providing you that protection that you need. So not to get into this too deep, but a pass score of 1 to 99 is going to indicate your place in the range before a 50% allowable loss. That's what you're seeing on this graph. And then from 50% to 100% of allowable loss, the system is simply going to show a 100 for the fail score. So that same principle is applying along both these lines. But so some of the things we've seen, the Scott respirator where we saw that if the seal starts to, so there's certain like things that can degrade within your respirator, that this is something that it could pick up on before it becomes an issue, because you have so much time between your fit tests, and this is something you'd be doing every day. So when you're getting all that repeat data is when you're going to be able to see as your score starts declining, you see a decline over time, you might know that there's something wrong with your respirator, that you can get the maintenance performed or the part replaced before it becomes a real issue. And so on that note, I'm going to hand it over to Luke. He's going to talk about some of the benefits for.
Yeah, so the benefits that come out of this advancement is not only are you doing daily wear seal checks or checking the integrity of the mask by seeing if you feel or sense a loss of pressure. We're doing a straight confirmation of mask integrity with this technology. And we're also allowing you to look at the verification of donning either before a shift starts or before you actually are wearing that mask into a hazardous area. So we have a number of use case scenarios that people are already using the technology where it's on shift change at a fire department, or they're preparing for a mission or whatever it might be, or they're getting ready to go on to shift or onto the work site. They're doing the test right then with the donning there. So the verification of donning. This one's a big one. It removes subjectivity. How do you know that your people are properly doing wear seal checks? How do you know that they're even being performed? How do you know that they're being performed correctly or that people are taking them seriously? So this technology removes that. It allows you to document it, which is the last point. So that's part of removing subjectivity and allow you to know that it's being done and having confidence in that. And that moves into the next point. We found that this has given wearers a lot more confidence in the respiratory protection they're donning and that they're wearing. What better way than in the COVID-19 situation we're in now than knowing that your mask is not just performing when you did a fit check 8 months ago or a fit test 8 months ago, but knowing that today, before you enter your shift, that your mask integrity is good, that you still know how to wear it, that it still seals properly, so on and so forth. And that's what this technology will do with instant feedback. So it's an 8-second measurement. You have a result at the end, and you're able to get all of that data documented and kept for safety and health professionals, which I'm sure many of you guys are. So imagine having not just fit test results, but fit check results for your staff and your people to know that their masks are working properly, looking at trends of those over time. All of that is possible with this technology. So those are just a few of the benefits that we found so far with this system. So next, what we want to do is move into a demonstration. So I don't know if you want to take off the screen, top right. Perfect. So let me try to bring some visibility to what we just went through. So I'm not going to go through what a user seal check or where a seal check is currently. What we want to do now is show you the technology. So we have a number of masks here. This is not a comprehensive representation of the full market, but what we do want to show you is a QuantiCheck device. So it's literally a handheld device that comes in a Pelican case or a Storm type case with a light extender. This light extender plugs into the USB-C port of the device and the same port that your charging cord would go in. So all of this comes with the QuantiCheck kit. all there. The version I'm holding now is what we call a DIN 40. In most parts of the world, in the US, we call it a NATO 40 millimeter type connection. So this connection will work with most every SDBA. So like Draeger, you would convert it to that mask, MSA G1, Scott AV2000 or 3000, and even some industrial masks like the Sunstrom mask has a 40 millimeter connection on that. So this device will connect to a number of different masks here. Then the other connection types that we have would be a connection type for, say, an APR 3M half mask or full face mask. That would just simply be a bayonet connection, just like your filters, to connect up to the respirator and to be able to do a check in that way. And then the final solution that we have available is actually a device that would go inside of the respirator. And this is something that we probably cover in a future technology webinar. But this device would stay with the user all day. It would actually measure their breathing, their respiratory rates. It would measure different fit checks that they would do throughout the day, and it would data log that in the device. All of that is through inside, the ability to keep it inside the mask. But what I want to do is demonstrate the external version, and we have a number of videos that you can go and download on the use of it inside the mask and other ways. But before I demo that, let me explain that the device comes in two versions. The first version is just a basic version. It gives you a red or a green light. The next version is going to be a Bluetooth enabled version, so it unlocks the ability to connect to the OHD QuantiCheck app, which you can download through Android or iOS. And then again, if you have a QuantiCheck with Bluetooth capability, it would connect to your app. You can do fit checks that way. You can then send those to the cloud if you have a cloud subscription to keep the data at a much higher level. But again, some people don't need Bluetooth. They don't want to track that as much. They just want a basic version, and that's something that can be done. So with that said, let me show you really quickly how it works. So button on the side to power on the device. What you'll see is the device will auto-calibrate itself, and then it will begin to give me a slow pulsating light to let me know that it's ready to test. Now you've seen on the app, the device is now discoverable. So if I touch it, it will launch the app and connect to this device so I can do a fit check there. So everything's ready. So the app is now seeing the device. It's now waiting for me to do a fit check. So what I'll do is choose a respirator. So I've got an MSA G1. I'll just thread the 40 mil or the DIN 40 in to the front. Just hand tight, doesn't have to be overly tightened there. And what you'll see is the light extender allows the employee or the wearer of the mask to see the results here or look on the app, whichever way they choose to do that. So I'm going to don the respirator, do a fit check with the QuantiCheck, and then what we'll do next is introduce some leaks. So if you want to talk them through that when I get the mask on so that they can hear, that would be great.
Okay.
All right, so let's see if I can see this.
Okay, so Luke's gonna see if you can show you the screen. Looks like you can see it, Luke. I can see the light in there. So you got to pass. Mask is fitting well.
So I'm going to now introduce a leak.
So he's getting the fail there.
So I'm going to remove it.
There you go, pass again. So you can see it's just really quick, easy way to evaluate that seal and your mask integrity. Get that visual representation. Feel good about your fit?
Yeah, so the way this would work in the field would be I would do my fit check, I would choose myself as a user. Once I get a pass there, I would then pass the device to the next person, or I would have it internal to my mask, all of those things. But really the confidence it gives the user is you don't have to wonder, did I do it correctly? Did I do it at all? Was there too much leak or not enough leak? For instance, I introduced this is a paper clip. So it is a paper clip. We just unwound the paper clip, introduced that leak. But when you have the mask on, you really can't tell how large of a leak is that. So the QuantiCheck removes all of that doubt and subjectivity, and it fails that to say, well, no, there's a leak that's consistently coming in. You need to, adjust the mask or check the integrity, whatever it might be. So the big thing to remember is on an industrial face piece, you have a number of valves that have to be replaced or removed. Anytime those get a hairline crack or a pinhole, you would need to be able to see that in a daily user seal check. And that's what this technology would allow you to do. So you know that your different inhalation or exhalation valves are working properly, that the integrity of the mask is good. So that's part of the advancements of the technology.
Well, that's the benefit as you move into collecting more of that data. That's when you can start evaluating your fit over time. So it's something like if you are used to, or as you go through your mask, you're normally getting a good pass on your QuantiCheck test, on your fit check, then you would know when you have an instant fail that something catastrophic has happened, you might adjust the fit, right? But if you're just seeing a slow degradation over day after day of that score just going a little bit down to the point where then you kind of look and go, wait a second, I've lost 30 points on what my usual pass score is, and it seemed to be that slow decline. That's when you might know that your mask needs some sort of maintenance. It maybe needs, the valve is starting to go. So you really get that benefit that you would never have with just a typical wearer seal check where you're supposed to be able to sense the amount of pressure you're either maintaining or losing. It really just gives you a lot more confidence in your fit, and it's going to get you. It's a really good training tool too, I think.
Absolutely.
I've gotten much more familiar with a lot of my different respirators going through the QuantiCheck testing just to see how, I just feel like I have a lot more confidence now when I don my respirator for how it's going to actually fit.
Sure. So Peter, that's the demonstration. Really, that concludes what we want to cover in our presentation and the demonstration. So I'm sure we got a few questions. Obviously, this is a new technology, so there might have been things that we glazed over that we're used to that might be not as clear to some of the attendees. So I don't know if this is a good time to pause for questions and really try to tackle some of those for the audience.
Thanks, Luke. Thanks, Luke and Stephanie. That's great. If anyone does have any questions, if you can just type them into the questions box. We've got one so far. So from Sean, is this portable system a potential replacement for the desktop quantitative fit test units?
That's a great question. Do you want me to tackle that?
You can go ahead, yeah.
Yeah, so that's a great question, Sean. This is not a fit test. It's just a fit check. So there's been no validation studies done or any research around this. It's a pressure decay technology, which is very good. But I think a fit test is at a much higher level. It's gone through peer review and a number of studies over a period of time to really look at the actual really accurate level of fit testing. And that's why this isn't really a replacement for fit testing. It's really to be a much better support of fit testing. So that's the answer currently. There is no plan to just replace the approved fit test methods that are there.
Well, there's also just practically speaking, you wouldn't be able to manipulate your respirator and perform that fit test. And also to go through a fit test, you would need to have a protocol. You then have to also get a fit factor. And so there's a lot of other things that play into that, just practically speaking, for what makes a fit test. So this is a huge improvement for wearer seal checks, current wearer seal check methods, but it's many steps away from what you would get from your fit test, where you're trying to find the best respirator for you from a selection of respirators. You're supposed to go through, there's a lot more to the fit test than even just the instrumentation. But anyway, I'm getting off on my own.
That's good.
Okay, we've got another question from Dean. Will you develop more connections to fit other ranges of RPE?
Yeah, absolutely. So we're in the works with doing that actively now. So every APR respirator that we're aware of, we will have adapters for. So Dean, if you have a respirator that you are currently using and you have an interest in the technology, you can reach out to AirNet and we can coordinate with them on what that connection is. But off the top, 3M, MSA, Draeger, Sunstrom, BLS, all of those are adapters we have on our fit testing method, the QuantiFit, and we'll have those same connections for the different respirators as well.
Thanks, Luke. From Mark, could the in-mask technology be applied to disposable respirators?
That's a great question. I think the in-mask technology, again, I'll jump in, you correct me, Dr. Lynch. The in-mask technology it would be wonderful for breathing, measuring breathing rates and different things in that way. The issue with the disposable mask is to be able to do a seal check. It's extremely difficult because you've got to cover, I'm sure you've seen that, but you have to cover the whole filter material. I've actually never been able to actually do it. And then create a suction on that. So it would be a stretch to get this technology to get to a mask that's meant to be just throw away. Because this technology is very accurate, very sensitive. I mean, you saw I slid a paper clip in and it failed it. So you're talking about a very slight leak source. And so that, from my perspective, that would be tough.
But when you think about how the filtering face pieces work, I mean, they're constantly leaking, right? But because you're using the filter media as the entire mask, so all the device would be able to sense is just total loss. It would have to distinguish between a really small difference in the pressure that would just be coming direct, and then the pressure that's coming in across a small pressure loss across the filtering media. So you're gonna have a lot of trouble distinguishing that leak, especially with something that doesn't fit great. Most disposable respirators, you are accepting a certain amount of leak that's higher than, say, with an elastomeric or anything like that.
It was just a comment from Mark. Figured it would be a tough ask, but had to ask.
Yeah, it's a great question. Yeah, absolutely.
That doesn't mean we're not going to still try.
Yeah, we'll try it for Mark. Absolutely.
Okay, great. That looks to be all the questions out of the way. So, if you've got any further questions on the OHD product range or anything that was discussed today, feel free to contact any of your AirMet sales representatives. And finally, sincere thanks to Stephanie and Luke for your time today.
Yeah, thank you for having us.
Thank you, Peter. Thank you, everyone who attended.